how is a walk cycle different from a run cycle? Well, how is a walk different from a run? First, let's open the standard BFDI assets file. We'll select all of the frames from frame 17 to the end across all layers. And then we'll right-click and hit Remove Frames, or press Shift F5. This is going to leave us with frames 1 through 16. That's for the 4 stages of our walk cycle, each stage showing up for 4 frames. Let's make a new layer for our leg. And I'm just going to remove the rest of these layers here, just to clean things up a bit. This layer I'm just going to rename to Leg. We'll go to our library and find Body Parts, Limbs, Legs, Leg Straight, and bring that onto the stage. I'm going to zoom in using Command plus or Control plus. And with the Transform tool activated, I'm going to double click this white circle to move the transform point to the top left corner. Now, in addition to our leg, let's add a guide, which will act as our ground. We'll make another layer below our leg and find the symbol in our library called Backgrounds Cloud 3. With our new layer selected, let's drag Cloud 3 onto our stage so that it ends up on the layer beneath our leg. I'm going to position it like this. Let's double click this layer's name and call it Ground Guide. And then we'll right click it and enable the guide option. So this cloud is here to simulate the ground for us. If we move this cloud linearly to the left, it'll be like simulating the ground moving past our leg. And it'll be easy to tell if our foot is sliding on the ground, since we can just see if the motion of the foot matches the motion of the ground. So we'll place a keyframe at frame 16. Let's change our zoom to 100% and move this cloud leftward by holding Shift and keeping it held while we press the left arrow key 5 times. And the reason we press Shift left arrow key 5 times is because that's the distance that we want our walk cycle to move over the course of 16 frames. We'll right-click the first keyframe and create Classic Tween. Finally, let's lock this layer. That's the speed our walking animation is going to be traveling at. Now let's plot out the actual leg motion. We're going to add keyframes to our leg layer on frames 5, 9, and 13. And this leaves us with an evenly spaced 4 frames per keyframe. So let's go back to the first keyframe and rotate the leg to the right by about 30 degrees, and it's going to actually snap to that angle as you can see here. The second keyframe is going to stay exactly how it is. And then the third keyframe is going to be rotated backward. Let's enable onion skin, and that'll help us see what it looks like compared to the other keyframes. So we're going to skew this a bit so that the tip of the foot stays on the surface of the ground. So we want it to look like it's rotated by the same amount as the previous movement. So looking at the previous keyframe here, we want to evenly space this out, so it's like the foot is moving backward at a constant rate. I'm looking at the dark space that these feet create, and it definitely looks like I want to move this leftward a bit. Alright, I'm happy with that. Finally, the fourth keyframe is going to have a bent leg. We'll make sure this leg is selected, and then go to the Properties panel and use Swap Symbol. We're going to select Leg Bent Above. We're going to use the onion skin previews to help guide us, so let's squash and skew this leg to give it a bent, curled up look. If we raise this foot high enough, we'll get the circular motion that we want. Now, we're done setting up our 4 stages. I've now disabled onion skin, and we're going to enable loop mode. I'm going to just resize this window to reveal that button. I'll drag this looping section to cover the entire timeline, and let's play it. I could remove this guide so that we're not distracted by the movement of that cloud. So we can just look at the leg movement itself. There we go, that's the gist of it. We've already got the skeleton of a walk cycle down. Very well done. Time to fill in our walk cycle with some in-betweens, bringing us from animated on 4s to animated on 2s. And that's going to help make this animation look especially smooth. I'm going to remove the loop preview and resize this window back down. Now let's put a keyframe at frame 3 and swap this leg straight with a leg straight scrunched. Now let's enable onion skin. What I want to do by using this asset is to get that scrunched look, like the heel is getting pressed on the ground as the foot hits the floor. I'm going to stretch out and skew this asset. And this is because I want to give it the right length and get the right angle for the heel that's pressed against the floor. And what's also happening is, thanks to onion skin being enabled, we're also trying to get the angle of the straight leg to be between the keyframes that come before and after it. Now for the next in-between. We'll put a keyframe at frame 7, and this one's pretty simple. We're just going to skew the straight leg, continuing the motion of pushing the ground to the left. For the next in-between, we'll put a keyframe at frame 11, but then we'll leave frame 11 how it is and go back to frame 9. See this leg here, it's the second to most recent keyframe that we can see here. This leg will also swap with leg straight scrunched. And this leg is going to have the toes pressed into the ground, while the heel is lifted. So we'll skew and squash this leg just right so that the leg's angle is between the frames before and after it. But this in-between is eased out because the angle of this leg here is a lot closer to the keyframe that comes after it. Finally, we'll put a keyframe at frame 15. In this case, we'll rotate this bent leg forward a bit, and maybe rotate the keyframe that came before it backward a bit, so that it's more similar to the straight leg that came right before it. You can see how throughout all these drawings, we're trying to maintain this consistent circular shape, where the foot positions are as evenly spaced as possible. But we are done. It's like we've doubled the resolution in a way. Now our leg motion looks so much smoother than before. I think now we're ready to see what it looks like on two legs. Now that we're animated on twos, I think our walking motion is smooth enough and well-defined enough to see what this looks like in context. Now, to be totally honest, one leg walking is not the most natural thing to see. Let's give our leg a sibling by moving it into a symbol so that we can reuse this. Let's select the frames of our leg and the guide layer, and right-click them. We'll hit Cut Frames, and then navigate to Insert, New Symbol, or press Command F8 or Control F8. Let's give this symbol the name Walk Cycle, and make sure type is set to graphic. Hit OK. Now we'll right-click the one frame that is there, and hit Paste Frames. Now if we back out to the main timeline, we can open up our library and drag the Walk Cycle graphic onto the stage, and if we play our timeline, we can see the graphic playing out as normal. One trick I recommend for duplicating something as fast as possible, even faster than hitting Command C and Command V, is to hold Alt while dragging. So I've moved the playhead back to frame 1, and while holding Alt, I'm going to drag our walk cycle symbol. In fact, let's hold Shift too, to lock the dragging to just a horizontal motion, and we'll let go of the mouse. So the legs are spread apart like this. And if we play it, well, this could totally work as a hopping motion, but to make this a walk cycle, what we'll do is change one of the graphics to be offset or staggered. So let's select either symbol. I'm going to select the one on the left, and go to the Properties panel to change the start frame. That's this field over here, next to the word first. Now, if we remember that our walk cycle is exactly 16 frames long, then we know exactly how much to offset it by half of the cycle. You might think that since half of 16 is 8, then start frame should be 8, but remember that the first frame starts at frame 1. And if we actually look at what frame 8 looks like, we can see on the timeline that we're not exactly halfway through our cycle. We should be on the first frame of the second half of this timeline, but instead we're on the last frame of the first half. All of this is because the first frame is called frame 1, not frame 0. If we want to give our left leg an offset of half of the whole cycle, we should start with 1 and then add 8 frames, giving us frame 9. Because of that, I'm going to change the leg on the left to have a start frame of 9. And now that we've used start frame to stagger the left leg by half a cycle, let's play it. Look at that. It's amazing how drastic of a change you can get just by adding staggering. It's like all the slow parts get filled in, and now the whole motion is continuous. We have now made a perfectly usable walk cycle from scratch. That is no small feat. Our walk cycle so far is animated on 2s, which is a perfectly usable number of frames for a smooth-looking animation. The issue is that if we put these two symbols in a graphic and tween it, we get this jerky looking motion. That's caused by the way in which we're mixing our frame by frame motion, which is on 2s, with the classic tween, which is on 1s. One of the rules of walk cycles is that any convincing looking walk cycle has to avoid the issue of feet sliding. We can't let any foot that's touching the ground shift at all. If we leave our animation on 2s, it'll be impossible to make a tween that matches the more jerky motion of the frame by frame. What this means is if we want this walk cycle to be usable, we want to make sure it looks good tweened. That means our frame by frame animation has to be animated on 1s, so it'll move in sync with the tween moving. So what I did there was just undo making that symbol and tweening that symbol. I'm going to dive back into our walk cycle graphic and go to frame 2. For our first in-between, we're going to look at the position of the leg and the general shape of the foot across the previous and following keyframes. So I'll place a keyframe on frame 2 and we'll just modify the leg that's already there. I'm going to make this foot fall down a bit. Next, on frame 4, we're actually going to copy the keyframe that's after it and just try to match the midpoint of the leg angles while keeping the foot on the floor. Now, frame 6 is probably the most straightforward one, since the previous and following keyframes are the exact same symbol. In fact, let's try using a classic tween to get the exact midpoint. You can see how this classic tween has perfectly interpolated the green and the blue shapes here. Although, since skewing works kind of weirdly when it's tweened, let's actually add a keyframe and scale this back so that the foot still remains flat on the floor. Now, to add an in-between keyframe on frame 8, let's just try our best to make the leg angle and most of the foot motion look continuous, because there isn't really much we can do to change the way the heel is still completely flat on the floor, whereas on the next frame it's perfectly lifted. So we're just trying to match the general shape here. And then with frame 10, let's skew the existing scrunched leg to try to continue the leg rotation, even though the heel motion isn't really all that smooth here. Next, with frame 12, let's squash this existing straight leg to try to match this arc that's in the movement. Frame 14 is another simple one, since this symbol is leg bent above in both the before and after keyframes. So again, we can try using a classic tween here to try to help us find the midpoint, though I would add a keyframe to this one too. And that's to sort of maximize the upward curve that's going on here, as the leg curves upward like that. So this keyframe here is to maintain that arch that's happening. Finally, the last in-between keyframe. Now, it doesn't look like frame 16 is an in-between frame, but since we're making a loop, this frame's actually in between frame 15 and frame 1. So to help us see where this frame should be heading, let's actually copy frame 1 and paste it at the very end to serve as a guide. So I'm going to right-click on frame 1, copy frames, and then right-click on frame 17 and paste frames. Now, thanks to our onion skin, we can now see where we came from and where we'll be heading. And we can see what we're actually in-betweening. I actually think this last in-between should be a straight leg, so that way this leg doesn't ease out before easing in with the leftward motion. So I'm going to delete the contents of this in-between keyframe, copy this leg, and paste it in place, rotating it leftward a bit. So that way, this foot is finishing its rightward motion before heading back left again. And then I'm just going to remove this keyframe here. So now we have a fully in-between walk cycle. You just animated this thing on 1s. That's the pinnacle of smoothness. Well done. And since you now know how to build this thing from scratch, you can actually make your own walk cycle of any length, not just 16 frames. How is a walk cycle different from a run cycle? Well, how is a walk different from a run? The speed, right? Isn't just running level 2 of walking? After all, if you need to get from point A to point B in less time, you're probably going to run, since that lets you cover more distance in less time. But the moment you speed up footage of someone walking, well, there's no way you're going to convince someone that this person is running or that this is someone walking. What's become clear to us is that you can tell if someone's running or walking, regardless of the speed that the footage is being played at, and also regardless of the actual distance they're traveling. If we take a bunch of footage of people walking and running and normalize the speed so that they're all taking steps at the same rate, it's still instantly obvious which people are running and which people are walking. What this means to us is that if we animated someone either running or walking, and someone else looked at how many frames long that looping motion was, the length wouldn't tell them anything that'll help them know whether the character is running or walking. If we want to make an animation where the audience can look at it and instantly know this person is walking instead of this person is running in slow motion, well, we have a few tricks in our toolbox that we can use to communicate that. Normalizing the speed of these walkers and runners helps us tune out the differences that might distract us from the parts that actually matter. Now, with all of these motions in sync, we can compare how their movements are different. And the most obvious difference is their posture. We could remove the motion entirely, and the people's poses would still tell us everything we need to know. The runners clearly have a much more exaggerated pose, and the bent arms and the lifted legs give it away. And the runners are also tilted forward. In comparison, the walkers are more upright, with the arms and legs remaining mostly vertical to save energy. Running is not an energy-saving motion, and most of the individual poses you'll see in a running person are less stable, since the body spends so much time on either 1 foot or 0 feet compared to 2 feet with walking. That brings us to another big difference, which is how much time the runners spend in the air compared to the walkers. There's so much vertical movement that each individual step is closer to a jump. It's the force of the back leg pushing against the ground that propels the runner upward, whereas with the walker, it's the front leg straightening out that causes the body to bounce upward slightly. Now, all of this real-life footage is going to look so much more subtle compared to a cartoon, which is made to be exaggerated. But understanding the real-life differences is going to help us stylize those differences, letting us communicate with the audience by making an animation that just feels like a walk, rather than a run or a jog. Now it's time for us to animate a run cycle. Even though there's a lot that's in common with the walk cycle, there's still a few key components that are going to be pretty different. Just like when we were first setting up the walk cycle, you'll start with the standard BFDI assets file and then trim all the layers down to 16 frames. So this run cycle is actually going to be the same length as our walk cycle. We'll add a new layer and rename it to leg. And once again, I'm going to remove these other layers. I'm going to bring in body parts, limbs, legs, legs straight. Zoom in and reset the transformation point by double-clicking it. First, we're going to lay down the main keyframes. Maybe I should call these the key keyframes. So our leg on frame 1 will start out by sticking straight forward like this. This is going to be when our runner is at the peak of their stride and both feet are in the air. One foot sticking as far forward as possible, and the other foot still recovering from pushing the ground backward. So after this, on frame 5, we'll add a keyframe to change this to a leg bent scrunched. I'm going to enable onion skin, and we'll rotate this downward. And try to squash and skew it, so it's like our runner is as low as possible, and they're in the middle of their bounce. Now, obviously, when you're running in real life, your body isn't going to be moving that low. But for the sake of our animation, we're going to exaggerate that up and down motion. So we're going to help the viewer see that bouncing motion that a walk cycle wouldn't have. But this leg isn't going to spend much time on the ground, since just 2 frames later, on frame 7, there will be another keyframe. I'll delete this leg and copy the straight leg from frame 1, paste it on frame 7, and change it to a leg bent above. And this is going to point backwards to a pretty extreme angle. That's for the peak of the running jump position, where one leg is sticking straight forward and the other one is recovering. Then for our last keyframe, I'll copy the one that's on frame 5, Command C, and paste it at frame 13. But I'll swap this scrunched leg with a leg bent above and rotate it so it's mostly pointing forward. It's like our leg bent above is unfurling into a straight leg, like it's an inflatable slide, like on an airplane. And that's our 4 key keyframes. Already, the timing of the keyframes is pretty different from the walk cycle, really hinting at the power of each swipe as the leg pushes against the ground and pushes the body back into the air. We haven't added the pushing yet, but we will. We're going to smooth out this leg in one go, one pass. Unlike the walk cycle, we're not going to in-between it so it's animated on 2s, and then again so it's on 1s. Instead, we'll use tweens. We'll put a keyframe right before the second keyframe. So this will be on frame 4. I'm going to re-enable onion skin so we can get a better look at this. We'll skew this leg and then squash it a bit, rotating it so that it's pointing a little bit more in the direction of the squashed leg that comes after it, even if the shape is quite a bit different. We'll right-click frame 1 and give it a classic tween, with the easing set to cubic ease in. Then, For the span of 2 frames with the scrunched leg, we're just going to fill in the blank space in frame 6 by adding another keyframe. So since this symbol has the foot pushing against the ground, we want to skew the bottom of it to the left. It's like the foot is pushing the ground in that direction. And we can't really do that very easily since this transform rectangle is at such an awkward angle. We want a horizontal edge that we can drag to the left, but there isn't one. Here's another pro tip. If your transform rectangle is at an oblique angle, but you just want to transform it along horizontal and vertical axes, you can use the brush tool to add a secondary element, just temporarily. So I'm going to press B to activate the brush tool, and just create some temporary stroke here. And now if you select both your symbol and the new brush stroke, it'll give you a fresh new transform rectangle that you can scale or skew however you want. In this case, I'm actually going to bring the previous keyframe, this one here. I'm going to try to skew this a little bit more to the right, once again using the same trick. And afterward, you can just delete that temporary brush stroke. And the reason this works is because the thing you want to avoid, which is this strange transform rectangle, is because Adobe Animate is remembering what transformation that symbol has. So the transform tool will always show you this same rectangle. But if you select multiple of anything, even if I just duplicate this by holding Alt and dragging, and if I select both of these, Flash now treats it like something that doesn't have a transform, since there's multiple items, and they could all have their own transformations. I'm just going to undo that there. That was just for demonstration. And of course, you don't have to use the brush tool. I could drag in any random symbol. And now, the transform tool is giving me a rectangle with orthogonal axes. Just anything that temporarily gives you an extra element, something that'll make it so that you're selecting multiple items. That'll work. So anyway, now this second keyframe of the scrunched leg is now skewed to the left a bit. On to the next keyframe, which has leg bent above, pointing pretty far backward. We want to transition into this pose from this one. So let's add another keyframe at frame 9. And then go back to frame 7, and let's re-enable onion skin, and rotate this leg forward a bit. And then also skew it, so it's like this leg is emerging from the scrunched leg that came before it. And then we'll give frame 7 a classic tween, and change the easing to cubic ease out. So we have the bent leg swinging into place. Now let's transition it into the following keyframe, which is also a bent leg. And that means we can just convert this keyframe into a classic tween. And then give this new classic tween an ease of cubic ease in. Now, in my opinion, this is now swinging too low. We want to preserve the circular motion of the foot, so we need to raise this leg somehow during this tween. And the way we'll do that is by adding a keyframe during the tween. And then we'll use our pro tip from earlier. We'll use the brush tool to draw a temporary shape, somewhere within the bounds of this symbol, and then select them both. With the transform tool, we'll then squash it vertically, and I'm holding Alt so that it's transforming against the opposite edge. And this is to bring that foot upward and try to maintain that more circular motion. Now I'm going to remove this temporary shape. Now, after having the leg speed up as it reaches this midway position, we want to have it slow down into its final pose, which is just whatever it is on frame 1. That's the straight leg. Brace yourself, because we're about to use a weird trick that applies to animating a seamless loop. We're actually going to copy the contents of frame 1, and then create an empty keyframe on frame 14 by selecting it and pressing F7. Then we'll press Command-Shift-V or Control-Shift-V to paste in place, and then add another keyframe at frame 17. Frame 17, that's after the end of the loop. Why would we do that? We're going to see very soon. Now, using the onion skin previews, we'll rotate the incoming leg on frame 14 downward slightly, so that it's slightly more similar to the bent leg that came before it. And we'll give this second to last keyframe a classic tween with cubic ease out. The last thing we'll do is add a keyframe on frame 16, and then right-click frame 17 and remove frames. What we just did there by putting a keyframe one frame after the end is we've simulated the way that a graphic loops. If we look at frame 16, the leg is almost at its final position before it goes to the next frame, which is actually frame 1. By putting a sort of placeholder at frame 17, we made it possible to start a tween on frame 14 and end it on frame 1. If we had just copied frame 1 and pasted it into frame 16, this leg would be duplicated. We would end up having 2 different frames with the exact same drawing. So that's a weird little detail about animating a seamless loop. Anyway, we are now done with our run cycle. For good measure, let's put all of this in a graphic. We're going to select all of the frames for our leg, cut frames. Go to Insert, New Symbol, and let's name this Run Cycle and make sure type is set to graphic. Hit OK, and then we'll right-click on this one frame and paste frames. Now we have a run cycle symbol that we can reuse however we want. Now we have our finalized, finished run cycle graphic that we can use however we want. I want to show you this tool that I made for Chapter 5 of Object Animator's Toolbox. This is meant to show a walk cycle in a programmatic way, showing that a computer can follow some certain rules to make a walk cycle that just clicks and, looks right. But the issue is that a lot of these rules are so intuitive and so based on what feels right that it's actually pretty complicated to try to implement it in code. So what I did here was I used 2 different sine waves, offset, to create the circular motion, but what I did here was I flattened the bottom of the circle that was created. And the reason that I realized that this was not going to work was that when the foot is on the bottom, it should be moving at a linear pace, but I realized that I can't really have it work that way. It's harder than it looks to make computers simulate these things that we can do naturally ourselves. You can see there's a bunch of different parameters that you can change. In this case, I have this thing that's just labeled gate, but this slider controls at what level the circular motion is being flattened on the bottom. And throughout the whole thing, you can kind of see how the way that when a foot touches the ground, it doesn't move linearly, sort of permeates through the issues with this. So when this circle is almost entirely flattened, you can see the feet are sort of dragging on the ground. That is almost like the floor has no friction to it. Maybe one of the issues is that there's no reason that this should act like the physics of real life, that these should act like real feet with mass and friction. By attempting to sort of encode these physical parameters in a much more simple way, makes me realize that now you're going to have to simulate the whole world if you want to try to simulate this thing in code. Now, the first slider actually doesn't do anything. I didn't program it to do anything, but the second one is what is going to set the size of that circle. That's the radius of the circular motion that these feet move in. Anyway, to conclude what I would like to say about this thing here, and that is an unfinished exploration into trying to code these problems, try to make programmatic solution to them. Unfortunately, it doesn't always work. Consider this an experiment. Sometimes the result isn't what you're expecting, but the fact that you got a result teaches you something. Now, you don't have to watch BFDI for very long to see that there are a lot of times where we just tween the body horizontally with the walk cycle legs tweened along with it. But in this course, we're going to do better than that. It's time to bring the body into the mix, because let's just imagine it. If you're going to be using this walk cycle or any run cycle, 10 times out of 10, there's going to be a body attached to it. And that body is going to have its own face layers. And a lot of the time, that face is going to be doing its own lip syncing on top of that. I just want to make sure you're prepared for that. Let's learn how to do that. I've set up this scenario where you're pretty likely to run into a similar thing. On these 2 layers down at the bottom are the graphics for the walk cycle that we made earlier. And then on the rest of these layers is where the rest of the body is. And we've got this wonderfully crafted facial animation where the whole upper body is pretty much how we want it. We just want to make this guy walk also. The first step is to select all of the frames across all of the layers of our upper body, so excluding the legs. And then right-click and copy frames. We'll make a new symbol by going to Insert, New Symbol, or pressing Shift F8 and naming it Bob Container, and making sure type is set to graphic. Now we'll paste those frames inside and head back to the main timeline. We'll make a new layer and then go to the library and drag Bob Container onto the stage. Here we're going to try our best to line up the graphic to be in the same spot as the original layers. And with the graphic in place, we can now delete those layers. And we have no reason to worry since those layers are safely inside Bob Container. Now to make bob container bob up and down. Now we already know that our walk cycle is exactly 16 frames long, but some new information is that in the span of one walk cycle, we want the body to bob up and down twice. So we'll make a keyframe at frame 5, and then another one at frame 9. This will mark the motion of one bob. On frame 5, we'll use the arrow keys to move bob container downward a bit. And we can use onion skin at all times to see exactly how much we're moving this. Then we'll select these frames and create classic tween. These two tweens are going to have the easing, ease in out cubic. So now we've just created the tweens for one bob. One motion down and one motion up. Now, this is the part where we run into a bit of a tricky situation, and a situation where I think it's a bit awkward with the way that Adobe Animate is designed. We want to loop the bobbing motion, but still continue the playback of our graphic, even throughout multiple loops of the bobbing motion. Now, as far as we know, the way to loop an animation is to put it inside a graphic. But if we do that, what we can instantly see is that the contents of that graphic get looped too, and there really isn't a way to opt out of that. We'll end up just seeing the first few frames of the graphic as the bobbing motion has reached its end, so now the whole thing jumps back to frame 1. Now, some users of Adobe Animate would solve this by switching the symbol type of bob container into a movie clip, which works differently from a graphic. A movie clip would loop through all of its frames with no regard for what start frame it's set to, since movie clips don't have start frames. They just progress through their own timeline, as if they have a mind of their own. Using the Properties panel to change bob container into a movie clip totally works, but within Object Animator's Toolbox, I don't recommend using animated movie clips, because the problem is that you can't see the animation when you're working on it. If you make bob container a movie clip, then Adobe Animate will only show you the first frame of it, even though when you go to render it, it'll display normally. It technically works, I just feel like animated movie clips can make things complicated to work with. That's why my solution is low tech. We'll select the frames from the first keyframe to the last one, and then we'll press Command-Alt-C or Control-Alt-C to copy frames. And then we'll select the last keyframe and press Command-Alt-V or Control-Alt-V to paste frames. And we're just going to copy and paste as many frames as we need, just to cover the length of the walk that we're making. Now, if copy-pasting one bob over and over is too tedious, we can always double up. So each step, we just copy and paste double the number of keyframes, and that will cover ground a lot faster. And if we play what we have, we can see how it's still just repeating the frames of the first bob. What we're going to do to instantly fix that, with almost zero effort, is we're going to select across all of these tweens, just overlapping any part of those tweens. We'll go to the Properties panel and make sure to hit Sync Symbols. Now if we play it, we have now looped the bobbing motion while continuing the face motion. For the last step, let's now select all of the frames of the two legs and the bob container. Right-click, Copy Frames, and then go to Insert, New Symbol, and let's now just name this Walk Container, and paste frames. Then we'll go back to the main timeline and place Walk Container on the stage. We can choose to try to line it up with the original layers, but we don't really need to since we don't have a background here. And I'm going to remove the original versions of those layers. Now this is the part where we finally add that horizontal movement. I'll put a keyframe at frame, let's say frame 80, and move Walk Container to the right. Now I don't know exactly how much to the right, so I'll just guess. If we add a classic tween now, we can see how correct our guess was. If the feet slide in the same direction as the body, then you're moving Walk Container too fast, and you need to move the position in the final keyframe backward. And if they're sliding in the opposite direction as the body, then you're moving Walk Container too slow. So you would need to nudge the final keyframe forward. Task complete. We have now created a walking motion and a running motion, and then used that walking motion in a real walking scenario. This has been Chapter 5, Walk Cycles. Thank you so much for making it to the end. The next chapter is Chapter 6, which is about how to use camera angles and backgrounds.